Hi Biobombs, I'm Anshika, and today we're going to be discussing the chemistry of life, which is one of the first chapters in AP Biology. So today's topics include elements, isotopes, electron energy levels in shells, covalent and ionic bonds, and how to make and break bonds. Let's get started. Elements cannot be broken down any further, and this is because they're made out of atoms, and atoms cannot be created or destroyed. Moving on, a compound is made up of two or more elements. An example of this is water, which is made out of 2 hydrogens and 1 oxygen. Essential elements are required for an organism, and trace elements are needed in minimum quantity. So, let's talk about some of the essential elements. Schnapps is an example of 6 of the essential elements that we need: carbon, nitrogen, hydrogen, oxygen, phosphorus, and sulfur. This is an example of an element. The electrons are over there and the protons and neutrons are in the nucleus. The electrons are orbiting around the nucleus. The protons and neutrons are held together in the middle using the strong nuclear force. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge, and these are all called subatomic particles. An important feature of elements is that they can turn into isotopes. The difference between the element and its isotope is the number of neutrons. They can either gain or lose neutrons in the isotopic form. As seen over here, 2 of the isotopes are carbon-12 and carbon-14. While some isotopes are stable, like carbon-12, others are unstable and radioactive, like carbon-14. The radioactive isotopes can decay and lose protons and neutrons, allowing them to turn into different elements. A real-world application of isotopes is seen in the Hershey and Chase experiment when they labeled proteins with radioactive sulfur and DNA with radioactive phosphorus. This allowed them to figure out that DNA was the genetic material because only DNA with the tracked radioactive phosphorus entered the cell. Moving on to electron energy levels in shells, the potential energy of the electron is determined by the electron shell it is on. The further away the electron is from the nucleus, the more potential energy it has. The electron shells consist of energy levels, which increase the further away it gets from the atomic nucleus, and the valence shell is the outermost electron shell. Going back to elements, to make compounds we need bonds between the elements. There are 2 main types of bonds, covalent and ionic. Water is an example of a covalent bond. In a covalent bond, the elements are sharing their valence electrons. The bonds can be polar or nonpolar depending on their electronegativity, which is based on how close the element is to fluorine. The electronegativity is the pull electrons have on an element. The stronger the pull, the more electronegativity the element has. As we said, water is a polar molecule. Water is made up of hydrogen and oxygen, and since oxygen is very electronegative, the electrons orbit around oxygen more than they do hydrogen. This is an example of a water molecule. As you can see, the delta near the minus sign and the plus sign stands for slightly, so oxygen is slightly negative because of its electronegativity, and hydrogen becomes slightly positive because the oxygens are pulling the electrons towards it, which prevents the electrons from getting too close to hydrogen, giving it a slightly positive charge. Ionic bonds have anions and cations, which are made by the transfer of electrons, creating ionic compounds. These compounds normally form salts. In this picture, the electrons are being transferred from the first element to the second element, creating the cations and anions. The second picture shows a covalent bond because they're sharing electrons. An example of this would be salt, NaCl, and the ionic bond between them creates positive sodium and a negative chloride. The cation is the positive sodium and the anion is the negative chloride. Some other types of bonds include van der Waals interactions. These are also known as London dispersion forces. In these bonds, the electrons are orbiting at different areas, creating slightly positive and slightly negative areas around the element, and this allows for an asymmetrical distribution of electrons and it lets molecules stick together. Another type of bond would be dipole-dipole interactions, and these occur in polar molecules. The partially positive end of an atom is attracted to the partially negative end of another. And the last one we will be talking about in this video is hydrogen bonding, which occurs when hydrogen is bonded to oxygen, nitrogen, or fluorine. We will talk more about hydrogen bonding in a different video because it's very extensive and important to AP Biology. Stay tuned for more videos on AP Biology. Thank you!